Jai Hind students. Today we are going to discuss another very important mathematical tool which we will be frequently making use in physics. And that mathematical tool is, students, logarithm. We will discuss about logarithm, the various laws of logarithm, the rules and what actually logarithm means. Right? So let's start with this session. So, logarithm, as I stated, it's a very important mathematical tool. And before we start with the definition of logarithm, let me give you some examples. Let a to the power x is equal to n, right? Suppose a to the power x is equal to n. Then log of, this is the short form of logarithm, right? Then log of n to the base a will give us x. So this is the result which we will be making use of in finding various formulas, right? So again I repeat, if a to the power x is equal to n, then log of n to the base a is equal to x. This is read as log of n to the base a, and that will give us x. I'll give you some examples, right? Suppose, first example, 2 to the power 3, we are aware it's equal to 8, no doubt regarding that. Then log of 8 to the base 2, it would be equal to 3. Understood, students? Let's discuss some other examples as well. Now look, 4 to the power 2, that will give us 16. Then log of 16 to the base 4, that will give us 2. Clear? Let's consider still another example. Suppose 5 of cube, that is 5 to the power 3, that obviously is 125. Then log of 125 to the base 5, it would be equal to 3. I hope it's pretty clear. So now, after this illustration, we are in a position to define log, right? So please listen to the statement very carefully. The logarithm of a number, again I repeat, the logarithm of a number to a base is equal to the power to which the base has to be raised so as to obtain that numerical value. Again I am repeating, students, the log of a number, let n be any number. So the log of a number with respect to a base is equal to the power to which the base has to be raised so as to obtain that particular number. So this is how logarithm is actually defined. Right, students? So let's make use of some important result using this illustration. For example, suppose we need to find out x to the power 0, it is always equal to 1. We are aware, anything to the power 0, anything raised to power 0 is always equal to 1. Therefore, log 1 to the base x is equal to 0. So this is a very important result. So please do remember it. Right? Also, y to the power 0 is equal to 1. Therefore, log of 1, using the same logic, log of 1 to the base y is equal to 0. So what do you conclude from this? From these two, we are able to safely conclude that logarithm of 1 to the base of anything is always equal to 0. Again repeat, logarithm of 1 to the base anything It can be A, B, C, D, E, whatever may be the base. Log of 1 to any base is always equal to 0. Clear, students? This is the first very important result. Let's discuss some other important results as well. Okay, we are aware this is the first important result, right? 2 to the power 1, it is equal to 2. Therefore, log of 2 to the base 2 is equal to 1. 3 to the power 1 is equal to 3. Therefore, log of 3 to the base 3 is equal to 1. 4 to the power 1 is equal to 4. Therefore, log of 4 to the base 4 is always equal to 1. So, what do you conclude from these? We conclude a very important result, that log of any number with the same base or to the same base is always equal to 1. This is the second very important result. Log of a number to the same base is always equal to 1. Right? That is what we have obtained over here. Right? Log of a number to the same base is always equal to 1. Right, students? Okay. Continuing with this, let's discuss some other important results as well. So what to do is, let's find out 10 raised to power 2. It is equal to 100. Right? Let's find out the value of log 100 to the base 10. So it is log 100 to the base 10. It would be equal to 2. Is it clear? So value of logarithm of 100 to the base 10 is equal to 2. Similarly, 10 raised to power 3, it is 1000. So from the same logic, what you get is log of 1000 to the base 3 is equal to the base 10, actually it is equal to 3. So students, these are the another very important results, right? Log of 100 to the base 10 is equal to 2. Log of 1000 to the base 10 is equal to 3. And here I must mention a very important point is that log of any number to the base 10, that is known as common logarithm. Again I repeat, log of any number to the base 10 is known as common logarithm. And log of any number to the base e stands for exponential. That is known as natural logarithm. This is natural logarithm. Log, suppose 10 base e. It is known as natural logarithm of 10. It is known as natural log. While log of any number to the base 10 is known as common log. Again I repeat, students. For common log, we always take base as 10. For natural log, we take base as e. E is the exponential. E is the exponential. And its value is 2.7182. It has a series, infinite series. 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial and so on. So its value comes out to be 2.718. Right? So this is the exponential. So log to the base e of any number is known as the natural log. Log of any number to the base 10 is known as the common logarithm. And students, always remember, in case you need to convert natural log into common log, you need to multiply by 2.303. What I mean to say is that, suppose natural log of 2 is to be found. Natural log of 2. So it will be equal to 2.303 common log of 2. So in order to convert natural log into common log, it has to be multiplied by 2.303. It has got a mathematical verification for it, but I will restrict myself to the result only, right? And before we start doing the laws of logarithm and doing quotients in physics, here I must mention that you remember the value of common log of 2. It's very important. It is frequently used in physics. So students, you need not to make use of logarithmic chart or logarithmic table. Please do remember this value. Common log of 2, it is equal to 0.301. This is a very, very important result. Even without the logarithmic table, you need to remember this particular value, because this value is frequently used in physics in several articles, right? So this is an important value which you need to retain. Now, before we start attempting some questions, we need to discuss some laws. There are various laws, but I will be discussing over here only those results or those rules which will be important in physics, right? First one is log m into n. It is given by log m plus log n. Here I must mention, if the base is not given, it is understood that we are considering common logarithm, that is to the base 10. So it is actually log m into n to the base 10. It will be log m to the base 10 plus log n to the base 10. This is the first rule, right? Second, this is basically the product. Next is, we'll make use of the quotient rule. So log m by n, it would be equal to log m minus log n. Here again I must mention, if the base is not given, it is understood that we are considering common logarithm, that is to the base 10. So this is the product rule, this one is the quotient rule. The other one is the power rule. M to the power n. It will be equal to m to the power n. N is the power. So it will be n times log of m. So these are the three rules which we will be frequently using in physics, right? So let's discuss some questions based on logarithm. Okay, let us find out the values of, say, log 8. These are the questions which we will be trying to attempt. Find the values of, okay, first is log 8 without making use of logarithmic table. Log 64, maybe log 200, right? Let's solve these questions without using logarithmic tables, right? Just making use of the facts which we have discussed just now. Just we'll make use of the rules. Okay, first one. It is log 8. Right? So as I mentioned, if nothing is given, it means that we need to consider only the common logarithm, that is to the base 10. Can it be written like this? Log 8 is 2 to the power 3. Isn't it? 2 to the power 3 is 8. So we can make use of the power rule. So it will be equal to 3 log 2. Which rule I have made use of? It is log m to the power n is equal to n log m. This is the rule which I have made use of. Clear, students? So, continuing, in the next step what we can do is, it will be 3 multiplied by log 2. I have told you to remember its value. The value of log 2 to the base 10 is 0.301. So that will give you the answer. 0.603. In fact, 0.903 actually. Right, students? So do remember this value. Log of 2 to to the base 10 is equal to 0.301. We will make use of this result very frequently. So that's the answer of the first part. Let's try the second one. Log 64. If nothing is written, no base is given, it is understood that we need to consider 10 as the base. That is, common logarithm is to be considered. So, can it be written as 2 to the power 6? Right? So, using the same rule, what we can do is we can write 6 log 2, which will give us 6 into 0.301. So, that can be easily solved. We can easily solve it. So, that is how make use of this result. Right? Third one. Log of 200. Let's see how to do it without using logarithm tables. Can it be written like this? 2 into 100. So we can make use of product rule over here. Log m into n is log m plus log n. So what we can do over here is we can write log 2 plus log 100, which can further be written as log 2, it is equal to 0.301, plus it can be written as log 10 to the power 2, isn't it? 10 to the power 2, that will give us 100. So it will be 0.301 plus 2 log 10. Again, make use of the power rule. 0.301 plus 2. We have discussed a very important result. Log of any number to the same base is always equal to 1. So log 10 to the base 10 is always 1. So what do you get? 2.301. So this is the answer. So students, I hope you have understood this concept, isn't it? So do practice such questions, right? Let's discuss some other question related to physics only, and where we will make use of this mathematical tool, which is logarithm. Students, in chemistry or in nuclear physics, we will discuss about half-life. Half-life of a radioactive substance. As the term suggests, half-life means it is the time during which half of the nuclei of a given radioactive atoms in a sample will undergo disintegration. So that is known as half-life, right? So it is found that during the radioactive decay, what happens is the number of radioactive nuclei that is left after time t is given by n is equal to n naught e to the power minus lambda t. Let's make use of this result. In nuclear physics, we will prove it, right? Now in the present scenario, let's make use of this result, right? So what is n? N is the number of radioactive nuclei present in the sample at instant t. What is n naught? N naught is the number of radioactive nuclei present initially, originally at t equals to 0. Lambda is the decay constant, which we'll discuss later on. T is the instant time, and E, as I've told you, it is the exponential series. Its value is 2.718, right? E to the power 1, that is the value of E is 2.7182, right? So, we need to find out the expression for half-life, right? So, N is the number of radioactive nuclei present at time t equals to t. N naught is the number of radioactive nuclei present initially. Initially means at t equals to 0. Lambda, it is constant, it is the characteristic of a radioactive sample. It is known as decay constant. It is known as decay constant. So, we are supposed to find out the expression for half-life. We are supposed to find out the expression for half-life, right? By using this particular expression. This is given in the quotient. So, by using this expression, we need to find out the expression for half-life. I'll represent half-life like this. T half. So half-life, as I have stated students, it is the time, as the term suggests, it is the time taken by half of the radioactive nuclei of the atoms in a given sample to undergo disintegration. That is, in this equation, if T equals to T half, if it becomes equal to the half-life, then the number of radioactive nuclei left in the sample would get reduced to 50% because half of the radioactive nuclei will disintegrate during this time. So then N would be equal to N0 by 2. Clear, students? So during half-life, the number of atoms, radioactive atoms left in the sample would be half of its initial value. So let's make use of this fact. So in place of N, we can write N0 by 2, N0 e to the power minus lambda small t. In place of small t, we will write t to the power half. N0 and N0 get cancelled. So what we get is half is equal to e to the power minus lambda t half. Clear? So rearrange the terms. We can write it like this as well. E to the power minus lambda t half can be written as reciprocal of e to the power lambda t half. Now comparing both the sides, what we get is 2 is equal to e to the power lambda t half, or we can write it like this as well, e lambda to the power t half is equal to 2. Now in order to get the expression for half-life, we take log on both the sides. So taking log on both the sides, we get, taking log on both the sides, what we get is log of e, and suppose we consider natural log, right? So lambda t half is equal to natural log of 2. So after this, what we have done is we have taken natural log on both the sides. So we will get this expression. Now using product rule, using power rule actually, log m to the power n, it's equal to n log n. So over here it is log e to the power lambda t half. So what we get is lambda t half log e base e. It is equal to log 2 base e, that is natural log. Clear, students? I have made use of here power rule. Log of any value to the same base is always equal to 1. So log e to the base e would be equal to 1. So we will be left with lambda t half is equal to natural log of 2. Therefore, what we get is half-life, it would be equal to natural log of 2 divided by lambda. Am I clear, students? Now as I have told you, we are not aware of the value of natural log of 2. So we need to convert it into common log. In order to convert natural log into common log, it needs to get multiplied by 2.303, isn't it? So what we get is 2.303, this is log base 10 2. So the natural log is converted into common log by multiplying or by introducing the numerical value of 2.303 divided by lambda. So now we can substitute the value. We all are aware of the value of common log of 2. It is 0.301 divided by lambda. Clear, students? On solving, what we get is 0.693 divided by lambda. So this is the expression for the half-life of a radioactive sample. This is a very, very important result which you will be studying in both the subjects, in chemistry as well as in nuclear physics. So students, I hope you will appreciate the application of logarithm in physics, and I'm able to convince you regarding the rules and all the basic knowledge about logarithm, right? So do practice some more questions, and I wish you all the best and feel confident, and do take very good care of yourself. Goodbye, students.